Well, this time we will solve some problem on series parallel connection. First we will consider the series connection of resistances, and we will see the voltage current across the resistances. Then we will connect these resistances in parallel and find the voltage or current, and we will compare these two. As the configuration changes, how the circuit behave, or the voltage current, how they are changing. So let us first consider the series connection of these two resistances, R1 and R2. R1 here is 3 ohm and R2 is 6 ohm, and these two are connected in series. You can see that they are connected in chain like fashion, and these two are connected to the 36 volt supply. So we first our aim is to reduce this resistances to the equivalent resistance. That means we should reduce this successively, so that finally it becomes the simple Ohm's law circuit, that is one resistance connected across the voltage source. But here only two resistances are given, and it is not such a complex circuit, but it will give us insight into the functioning of the different circuit and their behavior. So let us first find the equivalent resistance. What will be the equivalent resistance in case of series connection? The equivalent resistance, that we know that it will be the sum of the resistances. So here this will be the equivalent resistance, and this is 36 volt, and this is Req, that is equal to 3 plus 6, that is equal to how much? That is equal to 9 ohm. Okay, so R equivalent we found, that is equal to R1 plus R2, that is equal to 3 plus 6, that is equal to 9 ohm. Now that this circuit has reduced to this one, and now we can calculate the current flowing through this circuit. This current is I, and this current is the same I, because equivalent means what? This resistance, if it will be placed in place of this R1 and R2, that means in place of R1 and R2, if R equivalent will be connected, then the circuit condition will remain the same. That means the same current I will flow in this circuit also. So now we have found R equivalent. Now you can find I. I is equal to V divided by R equivalent, that is Ohm's law. So that is equal to 36 volt divided by how much is R equivalent, that is we have calculated 9 ohm. So we will get how much? 4 ampere. Now the current flowing through this circuit is 4 ampere, that means current flowing through this circuit is 4 ampere. So now we can find the voltage across these resistances. Let this voltage is across R1, it is V1, and voltage across R2 is V2. So we will find V1 and V2. V1 will be how much? V1 is equal to, again Ohm's law across this resistance, all the individual resistances, they will have Ohm's law. So V1 is equal to I into R1, that is equal to I is how much? We have calculated 4 ampere into R1. R1 is how much? This is 3 ohm. So we get how much? 12 volts. Similarly, V2 will be how much? That is equal to I, same current flows through both the resistances. So V2 is equal to I into R2, that is equal to 4 ampere into, now the resistance is 6 ohm. So we will get how much? 24 volts. Now you can see that V1 plus V2, how much we are getting? 12 plus 24, that is equal to how much? 36 volt. Yes, it should be, because these two voltages V1 and V2, they should sum up to 36 volt. Okay, now we are getting that. So you can see one thing, the voltage across the resistance R1, that is 3 ohm, is 12 volts, and the voltage across V2 is how much? It is 24 volt. We are getting 12 volt here and here 24 volt. Actually the resistance which is more, the voltage across the resistance will be more, because you can see it from here, V1 divided by V2 will be how much? V1 is IR1 divided by IR2. So V1 divided by V2 is equal to I will cancel out, so it will be R1 divided by R2. We are getting it, R1 divided by R2, 3 by 6, that means 1 by 2, and you can see V1 by V2 is 12 by 24, that is 1 by 2. So this is, so you should remember this formula. The voltage is proportional to the voltage across the resistance is proportional to the resistances when they are connected in series, and the current through them is the same. Now we will again see the behavior of the circuit, how much current is flowing and voltage when these two resistances will be connected in parallel. Now let us consider this circuit. Here the resistances are connected in parallel, and the same voltage source is here applied, that is 36 volt DC, and let the current in this main branch is I, and this through R1 and R2 the current flowing are I1 and I2. First here we have to calculate this R equivalent, so that this parallel connection will be reduced to the simple Ohm's law circuit. So we have to calculate R equivalent. We know that 1 by R equivalent, that is equal to 1 divided by R1, that is 3 ohm, plus 1 divided by R2, R2 is 6 ohm, that is equal to 6, it will be 2 plus 1, that is 3 divided by 6. So we get R equivalent is equal to 6 by 3, that means 2 ohm. So R equivalent we get 2 ohm. Now from this circuit we can find this current I, it is simple Ohm's law circuit. So I is equal to 36 volt divided by 2 ohm, that is equal to 18 ampere. Now this current is 18 ampere. So this current also, this is also same as 18 ampere. Now this 18 ampere current will divide between these two resistances, and we have to find this I1 and I2. I1 will be how much? I1 is equal to voltage across this V divided by R1. So I1 is equal to V divided by R1. V is how much? That is 36 volt. This voltage is connected across both the resistances. This 36 volt battery. So V is equal to 36 volt divided by R1 is how much? 3 ohm. So it will be 12 ampere. Similarly I2 is equal to same voltage, 36 volt, V divided by R2, that is 36 volt divided by R2 is how much? 6 ohm. So it will be 6 ampere. Now you can see that I1 plus I2 is 12 plus 6, that is 18 ampere, because this 18 ampere divides between these two branches. Now you can observe one thing, that what is the ratio of I1 and I2. I1 divided by I2, that is V divided by R1 divided by V divided by R2, that is equal to R2 divided by R1. We can see here that the current through the resistance is inversely proportional to the resistance. You can see that I1 is how much? 12 ampere, this is 12 ampere, and I2 is 6 ampere. I2, this is 6 ampere. So this branch here the resistance is less but current is more. Here the resistance is more but the current is less. R2 divided by R1, that is 2, but I1 by I2 is equal to 12 by 6, that is 2. In case of the series circuit, the main branch current is 4 ampere, but here in this case the main branch current is 18 ampere. It is much more because both the resistances are connected in parallel to this resistance. That's all for today, and next time we will discuss more.